Everybody, this is Mrs. Dinkelman, and these are the notes for Lesson 7.3, Slope Fields. Now, slope fields to me are really just a visual representation of what a solution to a differential equation might be. I would think we would tend to use these if we can't find the solution to the differential equation. So we kind of draw a little picture of it so that we can at least get the idea of the behavior of the particular function. So we're just going to draw some little picture some little tiny slope or little segments that have a particular slope on our picture. I kind of imagine these, if you've ever seen like not kind of like a topographical map, but like a map from above a mountain, and then you can see which direction the slopes are going, like kind of draw little tiny line segments, and sometimes they have little arrows on them as well. Or if you're looking at a river or a stream and they have arrows so you know which way the current is going, which I'd imagine that people who are doing river rafting, especially the guides, that might be something they analyze before they go out, and that could change based on the time of year and how much water is there. So I could imagine people using slope fields in that way as well. So on example 1 here, where they're just asking us to find the slopes, just give me a second, one note is stuck. This is part of what we're going to be doing. We're just going to calculate slopes at lots of different locations. So they're asking us to plug into that differential equation. So it's just going to be -3/2 and then +1/3, and then let's see, that's going to be 2 over -1, so -2, and then -2 over -2, so that would be a 1. Why can't we find slopes when y is 0? Well, because that means we have a 0 in the denominator, which means our slope is really actually undefined. Tends to be the slope is undefined when we have a vertical tangent line. So we can draw in little vertical lines, or a lot of times people actually just skip them. Okay, we'll see how many of these we do. So find and plot the slopes giving that. I think they must have given us points, hopefully, that we already found, maybe not. Nope, they already have those listed, I'm guessing. So we'll find the remaining ones. So you can see maybe what they've done here is, for instance, at 3, 2, so let's find that on our graph, 3, 2. That's that little tiny line segment. They were trying to draw it as if it had the slope -3/2. Okay, and let's look at -1, 3. So +1/3. -2, -1 has a slope of -2. And I'll kind of give you some advice on how we do those. So that's what they've done here, and let's try to finish out at least a few more of these and see what happens. So let's see. And sometimes, by the way, it is helpful to sort of make a little chart for yourself, especially if there's a lot going on and depending on how many they need you to make. So I'm going to try to do these here that are when y is 1. So we'll figure out what's happening at -1, 1, -2, 1, and -3, 1. Okay, so that's going to be a slope of 1, and then a slope of 2, and then a slope of 3. So let's see if we can draw those. So right here at -1, 1, I'm going to try to point it so that it just goes up 1 over 1 and just do a little line segment. They're not going to like meticulously measure if you have that exactly right, but the idea that like the next one, for instance, is a little steeper than the one you just drew. So I'm going to try to point it at up 2 over 1. So I'm going to try to point it up at that guy. So the idea that it's steeper, and then this next one is even steeper. Again, they're not going to meticulously look, but just trying to draw those. And then you'll also kind of notice some patterns in here sometimes as you're looking through. Let's see. I feel like theirs might be a little off there, but I feel like these are going to look really similar. So a shallow, and then a little steeper, and then an even steeper, and so on. So that's what we're going to do with our slope fields. I'm not going to spend the time doing that many because that seems like a lot. Generally, these happen on the free response, and they give you like maybe maximum of 9 points to draw at, or it'll be like a matching, which we'll see, or a multiple choice kind of thing. So sometimes they will ask us to draw a solution curve. So they'll say something like the starting point is 0, 1, and let's see how well we can do that. So 0, 1. I've heard somebody describe this as you're kind of swimming through the curve. Again, think about those like the currents that I was talking about. So your solution's supposed to represent a function, and we want to draw as much of it as possible on here. And so again, if we're trying to draw a function, we probably aren't going to draw the other side of this, although my brain sort of thinks this should be a circle, and I wish they wouldn't have given us a circle to think about. So if I start somewhere else, then it's just going to be a lot wider of a circle if I'm kind of swimming through the curve that it looks like it's fitting. Again, you don't have to be perfect, but if you kind of get the idea of what the shape might be. And that's what we're looking for in a slope field, is what shapes are we seeing over and over again, and I think these are kind of looking like circles. Okay, common error, sketching too far, something that's not a function, and yeah, maybe not including everything. That's just something we do. We could actually find this differential equation. We're not going to do it because we did that last unit. I just want to focus on finding the slope fields. Okay, so we're going to draw the slope field. We probably aren't going to do all of those. So this one I'm not going to draw a table for because it's just based on the y-coordinate. So I think there are some things we can do here. So obviously when y is 0, so all along this axis, we're going to have undefined slopes. So some people will actually put little vertical lines and some people will just leave them blank, and I don't care which way you do them. Okay, so when y is 1, all the slopes are going to be 1. So I like it when there's a nice pattern like this because it makes it a lot easier. So -1. I'm bad at drawing them when they're like this. And then at 2, try to just make them a little steeper, and so on. Okay, so -2. Again, hard for me to draw when it's not on a flat surface for some reason. Okay, so you get the idea. On here they're asking us to solve, oh, it says graph the particular solution. So let's see if we can kind of figure that out. -2, -1. Okay, so we definitely know there's something kind of going like this happening. And then I would be confused a little bit about what happens with that, but let's think about it for a second. So let's do this one. Generally getting steeper as we go. And it might be that there's just an asymptote there, so I would probably just kind of draw that particular thing in. Okay. So which of the differential equations matches the slope field? Okay, so let's kind of think. There's a couple things that I'm seeing. Like I'm seeing generally it looks almost like a cubic. So the derivative would be a parabola or a quadratic. So I'm sort of thinking I might guess that one. But let's see if there's other ways to figure that out. So I guess one of the things I'm noticing, I don't see any 0 slopes. I always like to see zeros because those are really helpful, but I don't see any zeros. So if I look at like y equal or y prime equals x, when x is 0, I should have 0 slopes. And I don't see 0 slopes up and down this y-axis. So that's why I would eliminate that one. And similar for b, I don't see 0 slopes when y is 0. And then on c, when x and y are equal, I should see a slope of 0. So like at 2, 2, I should see a 0 slope. I don't see that. And then between these two, it's a little bit more difficult to think about. Yeah, they're both positives. But if it's, let's see, let's think about this. Notice all along the y, I might have been wrong here. All along the y, they're the same. So I might have been wrong. Along the y, or along that, they're the same. And the x does change. So I think I was wrong. And I think that I should be at letter D. Because again, like on the x-axis, when y is 0, we get a bunch of 1s. And that makes sense to letter D. So that's kind of the way my brain thinks about matching those. And then this number 7 is just a little bit different. So the really cool thing about a slope field is it lets us know what the original function looks like. So that's what we're looking for here. We're thinking about a function that does this kind of pattern where it kind of decreases. So e to the x goes like this, so that doesn't look like a. E to the negative x does just flip this way. So I'm almost thinking it's that one, but we'll see. Negative e to the x just takes a and flips it below the axis. So instead of going like this, it's going to go like this. So that's not what we're looking at. I'm going to look at E next. So natural log goes like this, okay, not that one. And then negative natural log, again, would flip that on its end. So it would go like this. Could be that one. So let's look at between B and D. And, oh man, I think that the difference is on D, I shouldn't really be allowed to plug in any negative x's. There should be more of an asymptote. So I kind of drew it that way as if it had an asymptote here on the y-axis, and it doesn't look like our example 7 has an asymptote on the y-axis. So I am going to go with letter B on that one. Okay, so again, just to recap, slope fields are a visual for what our solution might be. So we use the slope or the derivative to draw it, but it tells us what the original function looks like. Okay, let me peek at the assignment really quick. Just see if there were any that I crossed off. Again, if you feel like overwhelmed by the number of dots you're having to graph there, don't panic and don't feel like you have to draw every single one. So there's some matching ones. That's more like what's on the AP exam. Okay, I don't think that I crossed any out. Let me peek at these integrals. I think I did cross potentially 18. No, I left that one. No, I did not. I think I crossed 18 out, or I should have. I think all the other ones are doable. Also in your packet, Gary printed an extra thing. That's really for if we're using this as a textbook and make you write your stuff down on paper, that we would have that to give to you so that you could draw all those slope fields. So, okay, go ahead and get started on slope fields.